So in this video, we're discussing lab 14, which is titration. Okay. So titration is a process by which you're able to determine the concentration of an unknown unknown concentration of a solution. For example, you have an acid, but you don't know what its molarity is, but you can take a fixed volume of the acid, say 10 mils or 5 mils, all right? And then you can take a base of known concentration and then slowly titrate or add dropwise the base to the acid till the acid and base neutralize each other, and the moles of acid equals the moles of base, all right? And you've reached the end of the reaction, or the end point, or the neutralization point, all right? Now you can then use the M1V1 is equal to M2V2 formula to then determine the molarity of the acid. So it'll look something like this. So you'll reach the end point or the equivalence point or even the neutralization point, all right? They all indicate that the moles of acid is equal to the moles of base at this point, all right? So this is where you've reached the end of the reaction, okay? So how is moles calculated? If you take the molarity of a substance and multiply it by its volume in liters, you will get moles, okay? So you will take the concentration, which in this case is the molarity of the acid, times the volume of acid, all right? So that essentially you're converting this to moles of acid. Again, molarity of the base times the volume of base, that's moles of base, okay? So when you apply this formula, the C acid times V acid is equal to C base times V base. Then how do you find the C acid? You divide both sides by V acid, all right? And that's what you'll do, okay? So if you divide both sides by V acid, you will end up getting the concentration or the molarity of acid, all right? So the molarity of base times its volume in liters divided by the volume of the acid in liters, all right? And that will give you the molarity of the acid. So molarity of base is in moles per liter, and that's M base in the formula. Molarity of acid is in moles per liter, or M acid, okay? So M acid times the V acid is equal to M base times V base. So how to find M acid, where M is equal to molarity, all right? That's an abrupt jump into this picture. Sorry about that. But here you can see that in the flask, Erlenmeyer flask, you have an acid, and you have to add water to increase its volume, all right? And then in the burette, you have base of known concentration, all right? You'll also add an indicator to the acid, okay? You need an indicator because otherwise you won't know when the base has neutralized the acid. In cases of HCl and any OH type of neutralization, the desired indicator is phenolphthalein, all right? Because phenolphthalein is colorless in, it's a dye, it's colorless in acid, but then it kind of turns pink when it's slightly basic, all right? So you'll be adding the base dropwise to the acid, okay? Till you've reached that end point where the acid is completely neutralized, and then the indicator turns slightly pink, showing you that you've reached the end point, okay? So the equivalence point or the end point is where you'll see the color change from the indicator, all right? So this color change has to be sharp, all right? So when you're going from colorless to pink, that's a very sharp change. It's not a gradual change, okay? Now this, the way you choose the indicator is it must have a color change very, very close to the end point, and that should be a very distinct color change, all right? So you can see here in this pictorial, all right, there's another dye called as methyl red, but if you look at its color change going from orange to yellow, it falls way below the end point, which is here, all right? So the end point is occurring here. Now, there's another way to also do the titration where you're monitoring both the volume of the base that you're adding, but as well as the pH as well, okay? Because pH is another way to indicate the equivalent, that you've reached the equivalence point, because you'll see a sudden jump in the pH, all right? So you can see that here, this at pH 7 is the equivalence point or the end point. Now, methyl red won't work, but phenolphthalein will work, because you can see that it is colorless up till here, but then when you go slightly beyond 7, when you're reaching 8, you can see it turns pink, all right? So you have to choose an indicator which has a color change very close to the end point or slightly above the end point, all right, okay? And that's why phenolphthalein was chosen for the titration of HCl with NaOH. Okay. The other thing is, you will see initially the pH is kind of holding steady. It's gradually increasing, but then there's a sharp rise when you get to the end point, and after that it gradually slowly increases, showing that it's getting more and more basic, okay? So at the neutralization point, I also have to point out that in this experiment, we are not monitoring pH, okay? We are simply noting down the volumes. So at the neutralization point, the reaction of NaOH and HCl is complete. They have neutralized each other, where moles of NaOH is equal to the moles of HCl, okay? So the balanced reaction for this neutralization is NaOH 1 mole with 1 mole of HCl, giving you NaCl and H2O. NaCl is neutral, stable salt, H2O is neutral. So you've gone from a high pH, a base, low pH, an acid, and to neutral pH, and hence the word neutralization, okay? So the procedure here is you move your cursor over the hydrochloric acid and sodium hydroxide on the material's shelf. Okay, you will then notice that the sodium hydroxide is 0.1 molar. All right, the HCl molarity is unknown, you have to find out. So then you're going to take the burette from your container's shelf, place it on your workbench, and then fill it up to 50 mils up to the top with sodium hydroxide. All right, so the capacity of the burette, it's calibrated to 50 mils. Okay, now take a clean Erlenmeyer flask and place it on the workbench. Add 10 mils of water to the flask. Remember, you need volume in order to visually be able to see your titration happen. All right, and to that 10 mils of water, you're adding 10 mils of the HCl. All right, so that increases the total volume of the flask, and it makes it easy for you to notice the color change, right? But when you're using, you do not use 20 mils as your volume, you still use 10 mils when you're plugging it into the MAVA, MBVB expression or equation. Okay. So add 2 drops of phenolphthalein to the flask. This is important. You must add the indicator to the flask, otherwise you won't see that color change. Drag the flask, place it anywhere on the base of the burette. Now it's connected to the burette, so that the liquid will start dripping from the burette into the flask. Okay. So you can use the black knob on the burette to control the flow of your titrant. Titrant is the NaOH, which is in the burette, okay? So you can either deliver one drop of the titrant with one click of the black knob, or you can deliver like a steady stream by clicking and holding. The longer you hold, more of it will be delivered. But I suggest you monitor very closely how much you want to deliver by doing a first, as recommended, a coarse titration. So a coarse titration is to find out where exactly that endpoint might be. All right. So you what you do is you add 2 ml of the sodium hydroxide to the flask, all right? And then each time you're clicking on the knob, make sure what the volume is in the burette, all right? Then you add another small portion of NaOH, all right, by just doing a series of clicks on that black knob, okay? So that your starting volume is 50 ml, okay? Remember that. So as you're going down, that volume is coming down in the burette. So literally when you are wanting to know what that final volume of the base that was used, it's like reading air, all right, okay, because it's calibrated from 50 to 00 being at the bottom of the burette, okay. So you're adding the sodium hydroxide in 2 ml increments, noting the level in the burette at each time you're adding sodium hydroxide. And then when you do reach your end point, you will record this last volume, all right, before you pass it, all right, because once you've passed and you get like a deep, like a magenta color, then you've kind of shot past the end point, all right, and that's not good because then your volume will be incorrect, okay. So suppose you went from 50 to 34 mil in the burette and you reached your color change or your end point, okay. So that's good. So 50 minus 34, that means you used up 16 mils of base to neutralize the acid in the flask, all right? But suppose you missed that endpoint and you went off to 32, all right? Now your value for the base will come out as 18 mils, which is kind of erroneous because it's giving you a false number because you've gone way past the end point, all right? So you want to watch carefully for that endpoint volume. Now remove the flask from the burette and then put it in the recycle bin. Now take a clean flask, place it on the workbench, add 10 ml of HCl, 10 ml of water, 2 drops of the indicator, and you are going to place it at the base of that new burette. Again, make sure that that new burette has 50 ml of the sodium hydroxide, okay? So you're going to run another trial, all right? You can't just take one trial and expect that that's it, right? In real life, you want to make sure you have reproducible results, and which is why it's recommended you whenever you're doing an experiment to make sure that your data is reliable by doing it at least 3 times, 3 trials, so that you know that the numbers that you're getting are valid, okay? So you can then do this fine titration. So you did a coarse titration to find out where the endpoint was, okay? So then what you can do is like do a fine stream, like you can control the volume so that you don't have to add it in 2 mil increments. You can kind of add it in a steady stream up till 16 mil, and then afterwards add drop wise till you reach to the end point. I'll have to stop here and we'll continue this in the next video.